So yeah, a very beautiful answer indeed. Okay, so we've got the integral from 0 to 1 of the square root of x plus the square root of x plus the square root of x forever and ever and ever. So what we'll do is we'll say that this thing is equal to y. And now, because this goes on through infinity, let's do infinity, we can say that this part of it is also just y. So we can write the equation that y is equal to the square root of x plus y. And rearranging this then, we have that y squared is equal to x plus y, and that y squared minus y is equal to x. So if we complete the square on this to try and find a value for y in terms of x, we'll have y minus 1/2 all squared minus 1/2 squared is equal to x. So when we take this half over, what we can say is that y is equal to 1/2 plus the square root of 1/4 plus x. Spot on. So let's integrate this thing then. So we have our integral I is from 0 to 1 of 1/2 plus 1/4 plus x, all square rooted. So if we write that square root to the power of 1/2, what we can see is that it's just going to be reverse chain rule. So the first bit, we're going to get x on 2. And for this thing, it's going to look something like 1/4 plus x to the power of 3 on 2. If we were to differentiate this thing, the 3 on 2 would come to the front. So to counteract that, we'll put a 2 on 3 at the front. And this then, we need to stick in 1 and 0. When we stick in our 1, we're going to get 1/2 plus, this is going to be 5/4. So we'll have 2/3 multiplied by 5/4 to the 3 on 2. And then we'll subtract when we plug in 0. So plugging in 0 to that gives us 0. And plugging in 0 into here, we'll still get the 2/3, nice and simple. And then our bracket will just be 1/4. So we'll have 1/4 to the power of 3 on 2. And now let's do some algebra. What we're going to get out, our half will stay the same. We'll have 2/3 multiplied by 5/4 multiplied by the square root of 1/4, which is going to be 1/2, multiplied by the square root of 5. So just the square root of 5. Take away then 2/3 times 1/4 times the square root of 1/4, which is 1/2. So when we evaluate all these fraction multiplications, we'll have 1/2 here. We'll add on 2 times 5, which is 10. And then 3 times 4 times 2. 3 times 4 is 12. Times 2, 24. Lots of root 5. And subtracting 2 times 1, so 2. Over the same denominator as the second fraction, so 24. So if we simplify these, we'll have 1/2 minus, we'll do the constant at the end. That's 1/12 plus 5/12 of root 5. And what we can see, this constant here will actually be 5/12 as well. So we'll take that out the front. We'll have 5/12 multiplied by 1 plus the square root of 5. And what we can actually do now, as the golden ratio is equal to 1 plus the square root of 5 over 2, we can use our 12th over here to make it into 1/6 and 1/12. So we can think about this as being 5/6 of the golden ratio. Lovely jubbly. What a beautiful answer.